We are live. Welcome to Cribl TV on a Friday. What a great day. Thank God it's Friday. This is Ed Bailey, Technical Evangelist from Cribl. This is Eugene Katz, the man, the myth, the legend from Cribl Professional Services. He's here today to help us introduce the first official Cribl reference architecture. I would have ballooners and banners, but no one ever did that for reference architecture. Reference architectures are so boring that there's no such thing as a meme for reference architecture, so you know. So, Eugene, tell me about yourself.
Yeah, so I came from a background of software development, worked on many things from SharePoint to Node.js apps to came this close to working on server-side JavaScript. Thank God that project moved somewhere else. And then I started working with Splunk, moved on to help manage a Splunk service for a customer, and then we brought in Cribl. Started running the Cribl user group because we needed a place to talk about Cribl other than the Splunk user group. And then I ended up at Cribl.
That's awesome. So what are you doing at Cribl?
So professional services, basically helping users get the most value out of what they purchased. Nice. So, yeah.
Yeah, I'm thrilled. This has been a great project. We're finally going to have an official reference architecture, and we're going to be Eugene and I are, for everyone, we are going to be back over and over again talking about this. Eugene, so tell me, can you tell me a goat joke or tell me the story about the goat that we see over your shoulder?
Yeah, sure. So my daughter has been doing art for a while, and, you know, for birthdays and such, she would make something or draw something. And then we thought, that just goes somewhere in a folder, whatever. Eventually,
oh, we're losing Eugene's audio. I think we are losing Eugene's audio. We may have to have Eugene rejoin. Let's see. Well, while Eugene's rejoining the stream, let me see. While Eugene's rejoining the stream, I just want to talk to everyone about the importance of a reference architecture. We're going to get you started there. And then also, we are definitely going to bring, I think we're going to have to get Eugene's kid on to make all of us, you know, goat art, because I think that's pretty cool. All right, Eugene's coming back in just a second. Go ahead and bring up the deck, introduction to the Cribl reference architecture. Reference architectures are great thing. It's a great starting point. We're going to talk about what is a reference architecture. It's boring, but incredibly necessary. I think it's incredibly also very, very important to emphasize. A reference architecture as a start is not going to be your end state goal. There are too many different ways to do logging, too many different ways to do Cribl to have every architecture. But the idea is that we want to get you 85% of the way there, get into a scalable deployment, so that as you new use cases, new data, you're able to scale and grow without a whole lot of pain. Also, we're going to give you like one of my favorite tips and tricks about how to get started with a reference architecture. We have a great joke to talk about where we're going to talk about it depends. It depends is the devil of architecture. You know, two things that lawyers and enterprise architects have in common is it depends. And also that makes them both, you know, it makes them who they are. We're going to have some general discussions about sizing, especially for planning for failure. We're going to talk about an all-in-one single worker group. We're also going to talk about a multiple worker group deployment, and then also talk about what's next and what we're going to do in the next couple of live streams in order to get moving forward. I see Eugene's coming back. It's almost there. Eugene.
Well, that was exciting. I did all the things and even rebooted the router this morning, but I'm on a hotspot now, so I'll figure out what happened later.
There you go. You know, it is the joy of technology. And by the way, we're all technology workers, so in all of a certain way, it's our fault. But, you know.
Oh, yeah.
So I got started. I went over the outline, the outline of our discussion points. So I'm going to go ahead and go on to the next slide. So we have a link to our first official reference architecture. Use the QR code. It is safe. It is non-boring. Oprah says you get a reference architecture and everyone gets a reference architecture. Gotta love Oprah for that. Special shout out to the docs team. We're very fortunate to have an amazing docs team who tolerates us all and makes us all sound like we know what we're doing. So thank you very much. Let's start out. What is a reference architecture and what is it not? So Eugene, you want to get started? I mean, and you've done this forever. For you, what's a reference architecture?
Yeah. So reference architecture, right? It's reference is key there. It's something that you can see, oh, this works in some cases, but then you can start thinking how it applies to your particular case and what, your environment demands and particularities need to be adjusted for. But it's a starting point, right? It's better than a blank canvas.
Totally agree. And that's the emphasis, starting point. Want to give you that 65, 75% lift to then match the reference architecture with your particular environment. The variability in IT is really hard to account for, but we also want to help people get started faster. One of the things engineers really struggle with is you got a new tool and what do you do with it? And typically you're going to figure it out, but you're going to figure it out by making mistakes. I made every mistake possible when I rolled out Cribl in 2018. And so I want to help you learn from my mistakes, our mistakes, and then get you started in a better place. But the emphasis, it's a starting point.
For sure.
I love this. So tell me, Eugene, so we got started in this project. Tell me the It Depends story.
So yeah, as I was going through and trying to find kind of what are the things that we should account for, right? What should go into the document that makes you think about different, considerations and demands on the system and what could happen. One of the threads internally in Slack was the answer from one of the founders. Well, it depends. I said, all right, I'm done. That's it. That's the whole document. It depends. But really what that means is, well, it depends on what. So that's what this document that we had the QR code for in the link really helps you start thinking about.
And that's one of the things I like most about it is the considerations, the context are frankly to me more important than the technical guidance of saying this much data and this many cores equals this, because you need that context in order to, in order to make any kind of progress. And also this is something that really bothers me about a lot of other different reference architectures is make themselves out to be suggestions, but they don't help you to find your end goal. They don't help to give you engineering goals. They don't help to bridge, from the start to the end. Also, there's an office meme for everything, and I really appreciate this. By the way, Eugene, so with your story, if it depends, you've now passed law school, so you're now ready to take the bar.
Excellent.
And this is why this is from my many years of doing this wrong is the most important thing you can do with any kind of new deployment, or if you're taking over deployment, is to define your end state first. What do you want your thing to be? What do you want your thing to do? For something that's mission critical, like your logging, telemetry, security logging, especially, the way I tend to look at it is you have to find what's your business objective first. And the idea is I want to say, okay, I want to have a scalable platform that is going to survive failure to a certain level. And that's where I like talking about in terms of my business objective. So for example, and that's why it's so important for especially the sizing discussion, is to what size do you want to establish it to be? Just incredibly common problem I see is someone says, okay, yeah, we average 10 T a day. But the key is you average 10 T a day. That's a good day. And that's where we're going to start with the 10 T a day is a good day. What happens on a bad day? What happens when things are really going wrong? And this is a very important discussion that you want to have with your business leaders is to what point can this fail? And so one of the things with my business leaders is we talked through this. And so we need to be survivable. We need our telemetry. We need our security to work when everything's going badly, because that enormous amount of data could be an indicator of an attack itself. Think about a massive DDoS. So we set the goal of 5x. And when I say BAU, that's our business as usual. And so that gave me an end goal to send, I could engineer backwards how many cores, how many systems, load balancers, all the different things of scale and sizing. because otherwise you're just picking a number out of thin air. And it's very important to have alignment. And where that alignment's really important, especially if you're working with the dreaded capacity team, is you need to be able to wave something around to tell your capacity team that, yes, I'm allowed to use this much hardware, and no, I don't have to give hardware back. Does that make sense, Eugene, if you're anything like that?
Yeah, totally. It's the analogy that I kept going through my mind as I was writing, and I think I wrote it into the document, is how many nines of reliability you want to pay for, right?
Exactly.
You can't pay for all of them. No, not enough money in the world. So at some point, you need to decide, okay, we're going to be good to this level. If it gets beyond, well, we know something is going to go wrong, but at least we're planning for a certain spike or whatever is happening.
Right. And also it just gives you direction. And that's why it gives you direction. It gives you a goal to work towards. You can always adjust that goal up or down later, but because otherwise you're going to guess. And you want to have alignment with your business leaders, set expectations appropriately. And then all the reference architecture suggestions start to make a whole lot of sense once you know where you're going. But the biggest thing you don't want to do is start with the deployment first without figuring out what your goal is. And if anyone has questions about this is critically important. Social media, Slack, we're always here. We're gonna start having some office hours for scaling the reference architectures as well that we'll announce in the Cribl community. So we want to help people because these are critical goals that you want to establish before you do your deployment. All right, Let's see what's next. So, Eugene, can you start talking us through, and this is why one of the key points about data in, data out, and start talking us through, CPU, memory, just general sizing considerations, and we'll talk about, why all this matters.
Yeah, so that kind of screenshot from our documentation, right? One physical core for each 400 gigabytes in and out of throughput. Or in plus out rather, not in and out. Is just that. It's general guidance. It's an approximation of what what assumptions you can start with, but that's a per day, and a particular part of the day might be busier, right? Even if we're not talking about something like an attack, right? So there's the spike because of normal activity during the day, but there could be a spike because of abnormal activity during the day. So when you start to look at those numbers, and the document goes into that, is what things you should consider and what you should multiply by in order to get your actual planned point to which you can still process data and not lose anything. But yeah, CPU.
Right. Well, so one thing I noticed is it says allocate one physical core. So what if it's a virtual core? Do I treat that the same, or do I need more virtual cores to be a physical core?
Yeah, so virtual core basically capacity-wise is half of the physical core, so you're going to have 200 there. It's still going to be the same number of worker processes, so that's where you need to know where your worker processes are coming from. So you can just say per worker process. Or if you have Graviton, that actually is a little faster than Intel-based. So we have all those details in the sizing documents, and a lot of good documentation from that team that'll help you get into the details, as well as even recommendations for certain, AWS or Azure deployments and which VMs to pick.
Yeah, and that's great information. So one of the things I would ask is one physical core for 400 gigs all the one physical core can do? Is there any kind of headroom there for change, for load, for capacity wise, or do I need to have another physical core behind that to handle spikes? I mean, I guess what I'm trying to say is 400 gigs the max that core can handle?
So per core, that's about it. I mean, there's some headroom built into it, but you're pretty much going to be doing that on one core. Now, again, it's in plus out, so you might have more sources, more destinations. It's splitting up across that, but that's where the distributed deployment part comes in, right? You're going to distribute not only across the different worker processes and individual worker node, but you're also going to have multiple worker nodes and scale out horizontally.
Gotcha. And I think those are key considerations, because as you size, you have to say, okay, where's my headroom? Where's my extra for that spike that we mentioned? So those are all critical. And also so with Cribl Stream, you can pass data through and not process it, not transform it, not enrich it. But how do you account for more regex, more transformation? Say I'm going to turn my Windows XML into JSON. How do I count for that in this sizing guideline?
Yeah, so that's where you really gonna need to see how much processing, right, that's taking up. We have in 4.0, I believe, we added the capability to do pipeline profiling, so you can, when you're running a sample, see how much processing that's using, how long certain expressions or evals might be taking. But that's part of the complexity, is that you don't know, right? You're not necessarily reviewing every single thing that gets deployed out there. You have a team of certain size. There are going to be people putting stuff out there. So it kind of gets into later points of, you want to have that capacity, and you want to isolate, in some cases, the more sensitive sources from potential effect by other sources or inefficient pipelines.
And this is something, and thanks Adil for the really nice comment. This is something that we are going to keep working on. We're going to have another live stream, actually several live streams in the next couple of months, talking in detail about each one of these subjects, because I think it's critically important to understand the difference between connecting, passing through data versus transformation, enrichment, reduction, because each one of those changes the mechanism. And so we're going to talk about how to plan for it and how to have a scalable architecture to handle it.
Yeah, and we have, like, memory is one of the considerations here, and one of the things that can take memory is if you have big aggregations, but also potentially large lookups, right? Those will get loaded into memory for each worker process. So as you start seeing what kind of processing you need to do, you're going to need to evolve that. You're not going to not necessarily know that right off the bat.
And I'm glad you brought that up. I mean, by default, each worker process gets about 2 gigs of memory. And this is something I learned the hard way. You start loading in those giant lookups, and suddenly that memory, you start needing more memory. Node.js is not normally a memory-hungry application. It's more CPU bound. But as you expand your use cases, you got to be ready to add more memory and add more resources as appropriate.
For sure.
So, so let's start talking about, this is something I totally just remembered. So as data comes in, there's buffering in memory as well. So this is something you want to watch carefully. Watch how your memory is being used, and we'll talk about this in more detail. So I put on the deck about disk size and speed, particularly around persistent queues. So Eugene, let's share a little about what is a persistent queue, why would you use it, and where would you use it?
Yeah, so you got data stream coming in, and you might have, let's say, a destination that you're trying to send to that's experiencing maybe a brief outage, maybe slowness due to whatever's happening, your indexers are rebooting or patching is going on downstream. So rather than losing that data or telling the upstream system, if it's capable of stopping to send it through, we have another option, which is write to disk, right? Have a buffer, but that's not just in memory, but actually on disk, that will A, be able to be larger, B, if the worker node is restarted, it'll persist. So, and that'll keep writing to disk depending on what behavior you set up, but basically until it runs out either of space on that disk or of the space you've allocated to that particular destination's persistent queue. And once the destinations are ready, at least one of the destinations is ready, it will start sending that persisted events in. So that does have to do with disks and speed, but it also goes back to, well, now you're really sending more data through, and depending if you have source persistent queue or destination persistent queue. So those are two different parts. This destination persistent queue, it's really already went through the whole pipeline. It's ready to go out to the destinations, just being written to disk instead. Where at the source, if you're queuing, it's going to have to go through that whole pipeline. So it's going to take those resources and processing as it flows through back all the way through the destination. So
yeah, I suspect we're going to need a whole show on just source and destination queues. So
yes.
let's go back just to destination queues. I think it's a great way to have a buffer. For example, say you're gathering the data in a data center in one country and you're passing it through into your security data lake before it's processed. It's really good to have that persistent queue in place before data is crossing a WAN to give you that buffer of, say, the WAN fails or Splunk on the other side fails. This gives you a whole lot of options. This gives you, a whole lot of options for preparing for failure. But then another thing is, and this is where those business objectives come in. How do you size your persistent queue? Because you're going to be landing a lot of data on disk potentially, and so do you have a 24-hour buffer, an hour buffer? And those are things you want to set expectations with your management.
You know what? It depends. Funnily enough, when we were sizing persistent queues, when I was on the customer side, what we sized them on is not how much data we want to keep total, but how long will it take for us to add more space to those VMs to increase the size of persistent queue, right? It wasn't, oh, we want to keep days. No, we wanted to keep 4 hours because within 4 hours, we can add enough space if needed. So it's a lot of it depends.
It really is. And also this is something we run into quite a bit. We've had customers who've talked about that, we need 72 hours of buffer space. For larger customers, that is an enormous amount of disk space that's just sitting there. And that's why I like your approach, is because you can use an LVM or some sort of expandable file system so that you can then automatically expand or plan to expand your persistent queue disk space, so you're not having terabytes of disk space just sitting around doing nothing most of the time.
Yeah, and just quickly, I know we don't want to dig super deep into it, but I alluded to how you can either specify the amount of space per persistent queue that it's allowed to take per destination, or you can just let it fill up a partition, and it's much preferred, especially if you have multiple destinations, to just be able to point to the partition, say, this is separate, this is not where Cribl is installed. If you fill this up completely, nothing is going to happen that's bad, because otherwise you're
I can't put it on my root file system?
No.
So one thing, and Paul has a great question. So tell me about what's the impact of the type of disk. Is slow disk going to be okay? Fast disk going to be okay? I mean, how do I account for that as well?
Yeah, so you definitely want to use fast disk. I believe the guidance is it 200 IOPS? How many zeros are there? I can't remember.
That's not fast disk. That's
2000, 2000, I believe. Okay,
there you go.
I knew there was a 2 in the front and a bunch of zeros at the end, but somebody said 200 and I didn't think that was right. Okay, yeah, so I believe that's where the recommendation is, and that's going to really matter for how quickly you can read and write. But there's another setting there that you have, which is whether or not you want to compress the data, and that in part depends how you're using it, right? How much disk you have versus CPU bound. But also, if you're doing something like a source persistent queue that's turned on to always write to disk, you don't want to be spending the time compressing it, uncompressing it every time. You just want to write it, uncompressed as fast as possible, right? And always on source queue. That's great for something like a UDP source, where if you miss something, it's gone, right?
And that's where there's a direct relationship between being able to clear your queue and the speed of your disk. Another thing to remember is when you're in an outage situation, whether it's WAN, whether it's Splunk or Elastic, you are going to be doubling up in terms of volume. So say you're 100 megs per 100,000 events per second. So you're going to be trying to clear 100,000 events per second while you're taking in 100,000 events per second. So just be aware you're going to have contention, and that if clearing your queue, taking hours to clear the queue is a problem, you have to plan accordingly. But just be aware that that's there. So Paul has a great question. So he wants to talk about persistent queues when using ECS and Fargate workers. Presumably EFS is the recommended disk. So what do you think?
I will say that my knowledge of specific disks and different deployments is not as great as you saw. I just mixed up the 200 and 2000, so you
it's all right.
have better insight into that.
So, Paul, EFS will work, but just what we were talking about, it's possible for the EFS file system to not exactly be as fast as it could be. So if you have a significant backup, it could take some time to clear. So you may need some faster options. Paul, if that doesn't make sense, please, we're both in the Cribl Slack community, so we're here to help you. But but EFS will work. And it's a lot of it, just like Eugene said, it depends on your requirements about how fast you need to clear your queue. So are you ready to move on to connection management?
Sure. Yeah.
So I think this is another big piece of, especially at scale, that is not as understood especially when you're working with tens of thousands of data sources, tens of thousands of universal forwarders, hundreds of potentially thousands of network pieces of network gear, that you need to have layers and need a plan to handle that connections. I highly, I can't say this enough, always have load balancers available if you're going to be working with agentless protocols like syslog, TCP syslog, UDP syslog, HEC, HTTP, but make sure you have something to manage that connection overhead. Don't point everything at one server, because you're going to get yourself in trouble. Eugene, do you have a perspective there to get started?
Yeah. So like you were just saying, you want to make sure you're balancing the load across the different workers, but then you have to account for what's the total number, right? So the reference document, I had a bunch of conversations back and forth, and really what it comes down to, right, there are certain things that have been tested, there are certain things that we see in the field. So like in the field, we see 400 connections per core, per CPU core, is a number that that's manageable, but it depends on the EPS, right? The number of events per second is a big factor there. So the guidance we give in the document is, if you calculate it out and you have more than 250 connections per core, then you need to start thinking about how many, start testing, right? That's where the it depends comes in again.
Very much so.
What do you have for EPS, and how sustained is it, and right, how many forwarders, how fast are they writing, do you have a big senders, right? So it can change drastically.
And this is where, if you're at a certain amount of scale, I would highly consider separating my worker groups in order to, because these are very different connection profiles for agentless. And also we talk about using the HTTP REST collector, where you're pulling data to Cribl. And so there's very different workload features here. And so this is something we're going to go into in more detail. We're going to beat this to death, because I think it's important that we talk about it, people understand it, set expectations accordingly. The agent-based protocols are going to be a lot easier to deal with. They're going to auto load balance. They're going to be able to buffer. They're going to be able to say, okay, this worker's busy, I'm going to go to another worker. So you're going to have much easier to manage, much easier to manage at that side, on that side of the house. But it's the agentless stuff that's the pain in the butt. All right, so let's go into our use cases. So this is what I consider a small medium architecture. We call it an all-in-one worker group, where you're pulling in your syslog, your Elastic Beach, your agentless protocols, all pulling it together. Now, we did include a dedicated replay worker group in Kubernetes. I want to emphasize, Kubernetes is not for everyone. It's probably right now only for some people, not everyone. So you can have this separate worker group for replay in just regular servers. And this is something that just as an example, but this is by no means required. So, but we're right now, between Eugene and I, we're going to focus in on the all-in-one worker group and just give you some examples. So Eugene, can you so let's say you were going into a customer engagement, fairly small customer, not enormous amount of data, say a terabyte. How would you handle this? How would you start structuring it? What are your considerations?
Yeah, so the big considerations are going to be I mean, to some extent, we're going to start going through the sizing exercise and the expected profile of the loads. But one of the things that we want to make sure before we decide on a single worker group is that what happens if one of the sources overloads, right? Like mentioned before, right? UDP, if you're too busy to receive UDP, it's gone. So if it's going to be all sources that can handle some sort of spike and hold off on sending, right, like agents that can deal with that, then we might be able to support that, right? Syslog, if it's TCP and the sender is aware enough to pause sending, if things are overloaded, that's fine. But
and also not high enough. If it's not, if we're not talking about big volume here, you have a lot more flexibility.
Yeah, fair point. If you're not likely to exceed your capacity even by one of the senders going wild, you're pretty safe.
And this is something I just want to bring up, and we're going to go into more detail. A Cribl worker process is assigned to a single core. And so the core is going to be the limit of that scalability. And so that's why having a spread of data over as many workers as possible is going to get you the best results. That's why we keep mentioning this TCP UDP syslog. If you're pinning, can create some problems for you. And so these are just the considerations to just things to take in consideration. And so much of it is just about that amount of load. Low level, a few hundred gigs a day is fairly manageable, even for TCP syslog.
Yeah, for sure. And I mean, that's one of the reasons, right? Even if this one of the simplest architectures, the replay worker group is already separate, because when you're replaying, yes, you might be pulling a whole bunch of stuff through. So you want to isolate that from other workloads.
Yeah, and the replay is a key feature, something I encourage everyone to do if at all possible. Write a copy of your data to an object store, so that way you can maintain first your retention. You no longer have to maintain your retention in your system analysis or in your SIM. Put it in your object group. It's going to be a generic format of data that you have control over, ND-JSON, it could be raw, and use replay. It's one of the best parts about Cribl, to visually go into the bucket, find your data, and then you can put that data to anything. Cribl literally reads that data out of the bucket, runs it through its pipelines. You can put it to Snowflake, Elastic. I mean, it want to be like Oprah, like you get some data, you get some data, you get some data. But it gives you a lot more flexibility than you have now. Because if you put your data directly in your system analysis, getting that data out of your system analysis can be troublesome. And so it's it's a great feature. So we're going to talk about this more too as well. Sorry, Eugene, didn't mean to interrupt. Go ahead.
Yeah, no, that's good. I think, I don't know if there's anything else until we flip over to the next one with multiple.
All right, let's go to the big daddy.
Yeah.
So large. So you're separating your worker groups. You're distributing your worker groups on-prem, in your cloud. You have a separate worker group for syslog. So tell me what you think. What are the considerations for that would make this sort of architecture appropriate?
Yeah. So this is like we were talking earlier about isolating the different types of sources, right? The ones that are more sensitive or that you might have more severe processing on in terms of complexity, right? That could tie up your workers and seeing how it might affect other sources. So, for example, right, keeping syslog separate from everything else and keeping that simple helps you be able to continue receiving that. But you have your pull worker sources and you push worker sources, and or worker groups is what I see as a very common split. Like the first thing that customers will do is split up pull and push worker groups, because your push worker groups usually somewhat consistent, right? So that's your syslog flowing in, that might be your universal forwarders, whatever it is, you're somewhat consistent and predictable. While on the pull side of things, like if you're pulling down CrowdStrike, I was just earlier this week looking at with a customer at it, and we're looking at the throughput, the daily rate, and oh yeah, that looks reasonable. And then we look and to see, yeah, it's every 5 minutes there's this huge spike and then zero, and then a huge spike and zero. So when you have pull sources like that, that are going to have very different profiles, mixing that with push sources might be problematic. So that's a good setup. And then if you have a bunch of those pull sources together, if one affects, one is affected and can pull slightly slower, that's not as big of a deal as when a push source gets backed up. Obviously, you don't want to leave it in that state, but as long as it catches up.
Exactly. And as you scale out, the one thing is also that your pull sources are going to be managed by the leader in terms of scheduling. And so you want to make sure that you have those sources fairly close to the leader so you're not running into network latency and then potentially having skipped pulls. And so those are all the things that go into that kind of design. One thing I want to bring up, especially using a Cribl Cloud worker group, we all have to go through pulling in data over the internet for one reason or another. A lot of cloud SaaS providers love to push data over the internet. I had a couple that just like, let's push syslog over the internet. I was like, all right, sure. CrowdStrike does a nice job because they're using an S3 bucket, but not all providers give you an S3 bucket access. So having that worker group that's out on a Cribl Cloud can be a real advantage from a threat surface management standpoint, because Cribl Cloud takes the brunt of exposing itself to the internet. You only have to secure your perimeter to Cribl Cloud. So it gives you an enhanced security, gives you a little extra scalability about how you're managing these very key over the internet data sources. For example, you want to instrument your laptops and start having your laptops send their data to Cribl Cloud, and then to funnel your laptop data. All of our users, that was one of the things as an admin. Everyone went home in 2000, and all of a sudden the network, the data just exploded. But a lot of the people, when they went home, they never got back on the VPN again. So I had thousands of laptops that just disappeared out of control, and so we had to come up with a way to push data over the internet. So that was really helpful.
Yeah. Sure. And then you got other reasons, right? So, for example, if you have pulling down from cloud sources, you want to have that near a worker group potentially deployed in the same cloud, right? So you're not going across regions and you're not going across clouds, especially if you're paying for those egress costs yourself, then that's helpful, right? Other cases might be if you have, certain data can't leave certain regions. We see that all the time as well. This is too sensitive to go out to the central worker group, right? This is going to stay local, get written local, and only a subset is going to get sent somewhere else, or some things are going to get filtered out or masked.
And this is another, I think, key pattern, especially as you scale out. You want to deploy your worker groups to where your data is. You want to try to avoid home running data from one data center to another to plan for failure, but also give yourself time to scale. Even WAN management. I've seen this over and over again, where if you're sending especially a lot of data from a data center in another country where the WAN prices can be really expensive, having the worker group to worker group communication could be key, because it can make your data dramatically smaller and give you the ability to pause flow at failure. Same thing for cloud, and as you're mentioning with egress costs. A lot of customers who they're using AWS as their security data lake, but they're using Microsoft Azure Sentinel as their SIEM. They want to be able to send data from one vendor cloud to another vendor cloud. That can be kind of complicated, but if you're having a worker group in both places, you have a consistent interface for getting it done, and you also have ways to make data smaller, manage egress costs, and also just with persistent queuing, prepare for any kind of failure.
Yeah, and that's important, right? You have your ability to reduce the amount of data, but also compression, right? I was listening for that keyword, and I want to just mention it because if you're going between worker groups, you can do that, and that drastically reduces how much is being sent.
It's really, really great. So we're starting to get low on time. Let's go into our closing remarks, and then we'll prepare everyone for what's next. So tell me a story. Tell me some advice.
You really need to start thinking about where things are going to go wrong, right? Like you can start at the simplest, right, single worker group, whatever, and start thinking, okay, what's going to break in this case? And that's actually how that document that's linked is laid out. We start with the simplest case. We say, even at single instance deployment, right? We didn't even talk about it here, but there are some cases single instance deployment can work. Those are just very simple cases. But then we talk about, okay, well, that breaks for this, and this. right? So then maybe you have a single worker group, and we get into the details of how a single worker group will have its limitations. So it helps you not just give you those examples, but give you that mindset of, okay, with this setup, what's going to go wrong?
Yeah, I think that's a great way to look at it. And that helps you by establishing those parameters first. That helps you give everything else you're designing toward that. So that's a great way to look at it. So Paul has a great question. It says, in a distributed environment, can you throttle ingest by way of worker groups, sort of like creating artificial quotas? And I think Paul's talking about an ingest, not on data going to your destination.
Throttle on ingest by worker. I mean, to some extent, you can if whoever is sending is able to adjust to back pressure, then you could limit that worker group and how much throughput you're able to you're processing, and as a result, it's just going to give back pressure to the sender, and that's gonna limit that. Not sure if that's exactly the question that.
Yeah, I think that's something like that, because you can throttle going to the destination, but I don't know of a good way other than the worker group running low on resources and exactly what you're saying, back pressuring. And that'll work with your distributed agents. Unfortunately, if your data's agentless coming in over, there's really not a whole lot you can do there. And just you just want to be real careful with agentless protocols trying to throttle ingest.
Yeah.
So I have a couple of closing remarks. I really appreciate everyone's time. This is a great conversation. Eugene, thank you. I can't wait to have you on again. So we're going to talk about this subject in a lot more detail. I think next time we're going to talk more about the all-in-one. We're going to lay out data flows. We're going to lay out things to think about. And also I think maybe we'll get into a little persistent queuing as well. And I think we'll do the next one next week. And so we're going to keep this going. Please, if we haven't answered your questions, Slack, social media, also your email address, ed@cribl.io. So we're here to help you. Paul, if you have some more questions, please hit us up in Slack, because we want to get your questions answered. Eugene, thank you very much. Really appreciate your time.
Thank you.
Yeah. We'll do it again soon. Hey, thanks. Appreciate it. Hey, the doc you wrote is awesome.
Great.
All right. Take it easy. Have a great day.
Bye. Thanks.